Alright, guys. So, warm ups, you're going to practice writing these equations in both y equals mx plus b form and graphing them using the x and y intercepts only. Alright. Example number one is to write the equation slope-intercept form. Remember, slope-intercept is y equals mx plus b. This is a formula where we replace m and replace b with points and letters. I'm sorry, I mistyped here. That should be 2 over 3. So our slope, m, equals a negative 2 over 3. Our b equals a negative 5, and we replace those in so that y equals a negative 2/3 x plus negative 5. Alright. B, we have a slope of 2 and it passes through a point of negative 2, 4. So we have two different equations we can use to solve this. The first we could solve for just b. The other, we could say y minus y1 equals m, open parentheses, x minus x1. I like to get things done all at once, so I'm going to use this second equation right here. y1 is 4, x1 is 2, so y minus 4 equals 2 times x minus a negative 2, which is going to make this a positive, so plus 2. Multiply the 2 through, y minus 4 equals 2x plus 4, and then add 4 to both sides, so y equals 2x plus 8 is my answer. Alright, let's slide over here and look at this in word form. Suzanne O'Connell is planning to lease a new car. The total inception cost, means her down payment, is $2,350. Her monthly payment thereafter is $325. Write an equation that models the expense y after x months. So, total cost equals y. Her cost per month, $325. Months are written in the form x, so 325x plus, how much was your down payment? $2,350. That's our equation for how much this car is costing her over time. Not too complicated, guys. Alright, and missing the other page. Where did it go? Alright, so third page. Example number 3, population. The age group consisting of individuals 65 years and older. Oh, you guys can't see it. Pay attention to what I'm doing. Here we go. The age group consisting of individuals 65 years and older has been growing for the last century. The table shows the annual percentage of U.S. population that has been 65 years and older since 1920. Find a linear equation that can be used to model and predict the percent of the U.S. population that is 65 years or older in any given year. So, we basically have a whole bunch of sets of points. We need to take these points and use them to find a slope. So, here's what we're going to do. We're going to say that our percent is y and our age is years. So, we're going to start with, we're going to use the very last 0.70 and 12.5 minus the very first point, 0 and 4.7. So, 70, and I wrote those backwards, I'm sorry. That needs to be 70, because that's my x on bottom. and 12.5 minus 4.7 on top. Alright, so 70 is going to stay 70 since it's minus 0. I'm going to come over here and work out 12.5 minus 4.7. Borrow there, carry the 1. 15 minus 7 is 8. Borrow here, make that 11. 7.8. So I get 7.8 over 70. I don't know, if I divide that by 10, I can get 0.78 over 7. I don't know if that does me much good. Better yet, let's see if we can go 78 over 700 and reduce. Divide those by 2. 78 divided by 2 is 3.9 over 350. Our fractions aren't wanting to play well with us, so let's make this a decimal. Alright, and decimal wise, let's use this one. So 0.78 divided by 7. Move the decimal twice. Dun, dun, dun. 0, 0, add a 0. Goes in once. There's 700. 8, 0, 0. Once. 100 again. 100. Add another 0. Alright, looks like we're going to be rounded at 0.11. Okay, rounded at 0.11 for our M. So M equals 0.11. Alright, and we need to find this as an equation. So we need to go for a y minus y1 equals M, open parentheses, x minus x1, close parentheses. Choose this very first point. So y minus 4.7 equals 11 times x minus 0. I'm sorry, 0.11. So y equals minus 4.7 equals 0.11x. Add 4.7 to both sides, so y equals 0.11x plus 4.7. Alright, assume that now that's our answer for A. Put a little A right here. Alright, assume that the rate of growth of this age group remains constant over time, and use the equation to predict the percent of U.S. population that will be 65 years of age in 2020. So let's write this down. Here's 20, 30, 40, and I say that because it starts at 1920. So 20, 30, 40, 50, 60, 70, 80, 90. So there is at 2000. There is at 10, and there is at 20. So I need to plug in 100 to solve for my 2020. So 0.11 times 200 plus 4.7. Alright, come over here and work this part out. 200 times 0.11. 0, 0, 2. 0 to hold my space. 0, 0, 2. 2 decimals. So 22 is my answer. When I add that up, equation says add 4.7 next. So, using our equation in 2020, we would say that this equals 26.7% of the population. B. You guys didn't see any of that work because I wasn't paying attention. So, here's me working it out as multiplication. Here's the equation we used for B. We replaced x with 200. I don't know why I replaced it with 200. It should be 100. I'm losing my mind. So that should be 1, 1, 11, 15.7. The answer to B is 15.7, not 26.7. Oh, it's a good thing I'll move that so y'all can see it. Alright, we will be diving into graphs of circles. Oh, this is a pre-calc question. Tell you what, this is a calculus question. Tell you what, I want you to research graphing circles because you will have to graph circles by the end of this year. Research circles and find for me the standard equation of a circle. I want you to find it and write it down. Shouldn't be too hard. Just Google, baby.